we balance an equation, we need to make sure that the number of atoms that we have on the left is equal to the number of atoms that we have on the right. And that's called, and I don't know if we wrote this down yesterday, but we're going to write it down now if we haven't, conservation of, the law of conservation. So we have conservation of matter, we have conservation of mass, we have conservation of charge, and we have conservation of energy. Okay, right now we're working on conservation of matter. So we're saying whatever I have on the reactant side, which is going to be over here. Hey, go away. Whatever I have over here has to be the same as what I have on this side. Okay, put your phones away. And we did this one yesterday, so I'll let you work on that one by yourself later. Let's look at number 2. No babies today. Okay. So I would suggest that maybe we put this stuff on a separate piece of paper, only because, actually, you know what? I'm going to do that, so that we have more room. And if you need paper, I'll give it to you. But let's work on number 2. It says KClO3 yields KCl and O2. Okay. So law of conservation says whatever I have on one side, the reactant side, I have to have on the product side. Does this equation obey the law of conservation as it's written? No. So let's go ahead and fix that. Now to fix it, we need to put coefficients in front. We cannot change the subscripts because the subscripts are dictated by the formulas that we wrote before. That's what we worked on for the first 15 weeks of school. Right, Mia? You awake? Okay, it's Friday. You can do this. It's just the last day. It's Friday. All right, let's make a line. Then what? I don't think that's very straight, but okay. It won't hurt anything. K, Cl, and O. I've got 3 different elements here. What's going on? Okay. 1 potassium, 1 chlorine, and 3 oxygens. Now on this side, I'm going to write the same list, keeping them in the same order. 1 potassium, 1 chlorine, but 2 oxygens. So they don't match. Here's where they don't match. So we have to fix this. Okay? So there's 2 ways to do this. We can say to ourselves, self, what number can I put here? Okay, let's back up for a second. Let me just say this because I said it once yesterday, but I'm going to make sure you understand. These numbers down here are allowing me to determine where I'm putting my next number. This 2 is lower than this 3. So I'm working on the product side. I know I'm working in front of the oxygen. The oxygen is here. So once I determine that the next number that I write will go here, these numbers mean nothing to me. Please erase them, cross them out, put a big X over them. I don't care what you do, but don't look at them ever again. Okay? Yes, it is aggressive. Because what happens is people say, oh, I made 4, and then they add it to this number. Don't add it. Recount everything that's up here. All right, now, what we're going to do is we're going to try to get whatever number I put in front of here times the 2, because I'm distributing it out, to get to 3. What number times 2 is going to get me to 3? It's not a whole number. 1.5. So let me put 1.5 there. 1.5. Now I recount. I still have 1 potassium, 1 chlorine, but now I have 3 oxygens. So it's balanced, correct? The problem is you cannot have fractions or decimals in a chemical equation like this. So double everything. What numbers are here? 1. So if I double this, I have to double everything. So now it becomes, that's black, 2, 2, 3. And I'm done. Okay? See how I did that, Mia? The other way that we could have done this, just for fun, to show you the same thing, we could say to ourselves, self, I have a 3 and a 2. If I multiply this by a 3, this will give me 6. These numbers don't matter anymore. Now I know that this side has to be multiplied by 2. Recount. 2, 2, 6. And then these guys don't match. I would come back and I would put 2, 2, and 6 here. Any way you want, it's the same thing. I don't care which way you do it. It's the same exact thing. Okay? All right, let's do the next one. Actually, let's skip the next one. Let's skip the next one. Go to number 5. So number 5 looks pretty hairy. All right, AgNO3. That's silver nitrate and magnesium chloride. Yield silver chloride and magnesium nitrate. Okay. Now again, Cameron, put that phone away, please. We're going to have to determine if this is obeying the law of conservation. So let's make a list of everything we have on the left side and everything we have on the right side. Don't write anything down, just look. Okay? I want you thinking, not writing. Okay. We have a silver, we have a nitrogen, we have an oxygen, we have a magnesium, and we have a chlorine. Okay? This side we have exactly the same. Silver, nitrogen, oxygen, magnesium, and chlorine. I just copied this list onto this side. 1, 1, 3, 1, 2. 1, 2, 6, 1, 1. Okay, did everybody agree that they don't match? Okay. Let's start with the AGs. They match. Let's go to the ends. The ends don't match. So I am going to work on the left side. I'm going to put a number in front of here because that's where the N is. What number am I going to put there to get me to 2? 2. Okay? Recount. Once you put that number in, you recount. 2 silvers, 2 nitrogens, 6 oxygens, 1 magnesium, 2 chlorines. Okay? Now, put the phone away, Ange. Okay? Now, we can keep going down the list. We're going to get to chlorines, or we can go back to silvers. It doesn't matter. Okay, let's look at the silver. I'm working on the product side. The product has a 1. We're going to put a next number in front of the silver. These numbers don't mean anything to me anymore. What number do you want there? 2. Okay, recount. 2 silvers, 2 chlorines, 2 nitrogens, 6 oxygens, and a magnesium. Now it matches, right? Should match. Okay. Now I'm going to show you how to do it a different way. Okay, just watch. Don't do anything. So we had silver nitrate. Oh, I have a skinnier pen this time. Magnesium chloride, silver chloride, and magnesium nitrate. Do you see that this is a polyatomic ion? And do you see that this is a polyatomic ion? Okay? You can simplify your life by leaving the polyatomic ions as an entire group. So when I draw my line here, instead of listing all the elements individually, I am going to list them as the cation, the anion, the cation, and the anion. As long as that polyatomic ion shows up on both sides of the equation, it will work. When it doesn't show up on both sides, then it doesn't work. Okay? So silver, nitrate, magnesium, and chlorine. Okay? Now when we count these guys, I've got 1 silver. How many nitrates do I have there? 1. 1 magnesium and 2 chlorines. 1 silver. How many nitrates? 2. 1 magnesium and 1 chlorine. Okay. Now all I have to do is the same thing I did before. The silvers match. The nitrates don't. So in front of here, I'm going to put a 2. Once I put that 2, these numbers don't matter anymore. I'm going to go 2 silvers, 2 nitrates, 1 and 2. Where's my next number going? On the right side in front of what? In front of the silver chloride. Okay, because the silver doesn't match and the chlorines don't match. I'm going to put a 2 here. Recount. 2, 2, 1, 2. Okay? So, you can do it either way, but this is simpler to keep that polyatomic ion together. Look at number 6. Okay? Do you see a polyatomic ion in that?
Yeah.
Okay, what's the polyatomic ion in there? SO4. Keep it together because it appears on both sides of the equation. Okay. Let's look at number 9. C8H18 plus O2 yields, that's the arrow. You see that 1? That's a typo. It should be a C. CO2 plus H2O. Fix that. Number 9. Take your pen. Change it to CO2 plus H2O. Not 1O2 plus H2O. CO2 plus H2O. I think that was the only mistake on that. Okay, look at number 17. It says HCl plus CaCO3 yields CaCl2 and H2O and CO2. Okay, do you see any polyatomics in there? The CO3, good. Does that CO3 appear anywhere on this side? So you have to break them apart into their elements. Okay, you want to do this one together and then I'll let you work on the rest by yourself? Okay, H, Cl, Ca, C, and O. H, Cl, Ca, C, and O. I keep them in the same order. So that way, lining them up, I'm not going, how many H's, how many H's? I have them all lined up nice and pretty. Let's put a line here so we can see the difference. Okay. 1 H, 1 Cl, 1 Ca, 1 C, 3 O's. All right, what do we got going on here? We got 2 H's, 2 Cl's, 1 Ca, 1 carbon, 3 O's. Oh, it's actually a pretty easy one to do. Okay. What am I going to do next? You want to do the hydrogens? Doesn't matter in this case. But I would always suggest leaving hydrogens and oxygens to last. Just get in that habit, okay? But it's not going to matter because we're working in front of this HCl right here. What number should I put here to balance that? 2. Okay? This becomes a 2, this becomes a 2. This stays the same, this stays the same, this stays the same because these numbers are gone. Now does it obey the law of conservation? Yes, sirree, Bob. What is the sum of the coefficients in this equation? 2 here. What's the number here? 1. So 3, 4, 5, 6. These are all 1s. And we want the sum of the coefficients. Sum means add all the coefficients together. So 2, 6. Okay? It's just that they asked that question, and I want you to understand how to do it. When there's nothing written there, it is a 1. Okay? Alright, try some of these on your own now. Try them. I'm here if you need help. I'll put the answers up for you if I can find them. Let me stop the tape.